Okay, hi. Um, so today I'll be going through operation of sets. So operation of sets is in the SPM syllabus, the Form 4, Chapter 4 topic. And this topic um, is for if those SPM students who want to recap back your Form 4 chapters or all these Form 4, all of you Form 4 who want to who are newly introduced to this topic, this video will be informational to you. So the subtopic of this topic is intersection, union, and combined operation of sets. So I'll go through it and I'll list out all the important points and also a few examples to help you through to understand this chapter better. Okay, so the first subtopic, intersection of sets. So the symbol used for intersection of sets is an inverted U. And for any two sets, A and B, the intersection A intersect B read as this, alright? So basically, intersection lists all the elements that are present in both sets, the common elements of two sets. And in this example, you can see set C has 1, 2, 3, 4, 5, and set D has 3, 4, 6, 8. So the common element in both sets is 3 and 4. So you can see C, the inverted U symbol, C intersect D is 3 and 4. Okay, so this is simple. And I'll move on to the next one, which is... Alright, so right here I have an example of intersection of sets for you to understand further. Okay, so in this representation is typically how a Venn diagram will look like. But in here, there's not a lot of specification or anything because this is just a simple example of what intersection of sets is. So the yellow part will usually be the universal set, and the orange part will be one set, and the green part will be another set. So in here, we are assuming that the orange part is A and the green part is B. So the A intersecting B will be Ralph and Emerson. Okay, so that's all for this example. Okay, now we'll go through the next subtopic, which is union of sets. Union of sets is the set that contains all the elements present in both sets. Okay, so the symbol of union of sets is a U, opposite or intersection of sets. And it's easy to remember if you think of like union U, right? So union is everything. C union D would list all the elements of set C as well as set D. Okay, so for an example, you can see here, set C is 1, 2, 3, 4, 5, and set D is 3, 4, 6, 8. So C union D would be 1, 2, 3, 4, 5, 6, 8. Okay, as you can see, like some of it is repeated, like 3 and 4 is repeated in set C as well as set D, but you don't have to repeatedly write like 3, 3, and 4, 4. You can just, as long as it's same, you can just equate it to 1. So 1, 2, 3, 4, 5, 6, 8. Okay, there's no repetition when you write down a union. Okay. Alright, so this is a representation in a Venn diagram, and you can see like there's a lot of ways to show a union. A lot of sets can be union, and they can look very different. So the first one is A union B, where the sets are not touching at all. This is like in a Venn diagram. So this is the shaded part. And the second part is where there's an intersection. So when there's an intersection, the entire thing is A union B, and this is for a set of 3. All right, so you just see a different representation of how a union will look like. All right, so this is an example of a Venn diagram, a simple example of a Venn diagram, and so we are assuming that A has 1, 2, 3, and B has 3, 4, 5. So A union B would be 1, 2, 3, 4, 5. Right? Simple. Okay, so I'm just going to go back briefly through intersection and union before we move on to the next part. So for intersection here, you can see that P intersect Q is the shaded green part. So the part where there's a common element between two. So as you can see, P is intersecting Q, right? So, and P union Q, as you can see here, it's like the whole part is shaded. So the entire diagram here is the union. Okay, so I guess this is simple, and I'll move on to the next part. Okay, so complement of sets. Complement of sets is the set that includes all the elements of the universal set that are not present in the given set. Okay, so basically it's the opposite of what a union is. Alright, complement is everything that is not present in a given set. So if universal set is having a subset B, then the complement of set B is all the element other than element of set B. Alright, so I'll go to examples to explain. So okay, you can see this. So let's say A, right? A is the shaded part. So A complement, which is this apostrophe sign, it can also be a C. Even C would represent a complement set. But usually a lot of us use the apostrophe sign. So the apostrophe A apostrophe is A complement, which is everything other than A. Alright. Okay, and then now I'll go through an example of complement of set in an intersection of set and a union of set. So an intersection of set, as I went through just now, P intersect Q, in the first example, it was only shaded in the middle, right? So P intersect Q complement will be everything except for P intersect Q. Okay, the green part shaded here. And for the union example, you can see here that P union Q, and then there's this apostrophe sign out, which represents as complement. So P union Q is everything except for P union Q. Alright, P union Q complement is everything except for P union Q. So refers to all the elements which are not in set P and Q. Okay? Alright, okay, so now I'll go through the third subtopic, which is combined operation of sets. Combined operation of sets is where the operation of intersection, union, and complement are all combined together. And I'll go through a few examples to see how the questions will look like in exams. Okay. Alright, so here we can see that there's three sets here, P, Q, R, and this is a Venn diagram. The circle representation is a Venn diagram, and so such that universal set P union Q and R. Okay, so they ask you to list all the elements of P intersect Q union R. Okay, so how to do these questions is that first you slowly take out the information that you need, which is P and then Q union R, and then at the end you see what you can take out what is intersecting between P and Q union R. So for here, for the example in A, set P has 2, 3, 6, and 7. Okay, and Q union R is 1, 3, 4, 5, 8, 9, 10. Alright, and then after you list out both of it, P, Q union R, then you can see what is intersecting in between. So you compare P and Q union R, and you can see that the intersection between the two is 3. So 3 is your answer. Okay, so this is how you do it. And then for the example B, Q intersect P union R. Same thing. List down Q first, which is 1, 3, 8, 9. And then you list down P union R, which is 2, 3, 4, 5, 6, 7, 8, 10. And then between this both, you see what is intersecting. So you can see here the common element is 3 and 8. So Q intersect P union R will be 3 and 8. And then for the third example, you can see that the operation is in front. Okay, the bracket operation is in front, still the same thing. So Q intersect R. First we'll see what is Q intersect of R. So here we can see that Q intersect R is 8. And union of P. So list down what is P first, which is 2, 3, 6, 7. And then Q intersect R union P is all the element present in both sets. So 2, 3, 6, 7, and 8. Alright? Okay, I'll go through a next example. Okay, so for example 2 here, there's no Venn diagram, but it's still the same thing here. So A union B complement intersect of C. So first you list out A union B complement, which is everything except for A union B, which is, alright, what is not there is 31. 31 is not in A union B, and then 35 is not in A union B, 37 and 40 is not in A union B. So that is the complement of A union B. And then for C, you list out everything, which is already given here. And A union B complement intersect C would be the common element of both of this is 35 and 40. So that is your answer. Okay, and then for the next one is A complement intersect of B union C. So A complement is everything except for any element that is existing in A. So no 30, no 31, no 33, 36, and 39. So the remaining will be 31, 32, 34, 35, 37, 38, and 40. And then B union C is everything existing in B and C, which is 30, 32, 34, 35, 36, 38, 39, 40. And A complement intersect of B union C, the common element between both of this is 32, 34, 35, 38, and 40. Okay? And the last one here, it's the same thing. A intersect C, complement, union B intersect C. So first we list out A intersect C complement. So A intersect C complement is everything except for A intersect C. So everything except for A intersect C is 31, 32. So what are not the common elements in A and C, except for those. Okay, so 31, as you can see here, the common elements is 30, 30 and 39. So everything except for 30 and 39. Alright, so 31, 32, 33, 34, 35, 36, 37, 38, 40. And B intersect C is common elements existing in B and C, which is 30, 32, that's all. Yep. And then union is both sets together, everything that exists in A intersect C complement and B intersect C. So 30, 31, 32, 33, 34, 35, 36, 37, 38, and 40. Okay. Okay, so this one is the last part. This is exactly the same, but this is just shading inside a set, a whole Venn diagram. Alright, the first shade the gradient A intersect C complement. So the common elements of the common elements of A and C is 39 and 30. So everything except for 39 and 30 you shade. That is A intersect C complement. Okay, and the second one, B intersect of C, meaning the common elements in both B and C, which is 30 and 32. And for the last one, looks a bit complicated, but it's still the same. Okay, so A intersect C complement. So A intersect C is 39 and 30. And then the complement of that is everything except for 39 and 30. And then B intersect C is 30 and 32. So, and then the entire union is there, shaded in purple. Alright, so this is also simple. Alright, so thank you. That's all from me. I hope that makes it, I hope you understand the topic better. And good luck for your exams. Alright.